Hello learners, this is Dr. Jagpreet Kaur. I am working as Assistant Professor at Department of Education, Punjabi University, Patiala. Welcome to this session on domains of science. Science as a discipline has its unique perspective. Science is not limited to observation, experimentation and analysis only. Rather, it is a way of life. Science is an expanding body of knowledge through process of inquiry. India may be the only nation with a constitutional provision as fundamental duty to develop scientific temper among its citizens. Article 51A H is to develop the scientific temper, humanism, and the spirit of inquiry and reform. This reflects how we thought about science. For us, science is neither a pedagogical discipline nor a group of certain subjects. We have perceived science as a way of life with rational thinking. This feeling and understanding should be inculcated among the learners since childhood so that they can perceive science as a part of their life, as a way of their life. Our scientific traditions are ancient and our perception about science is associated with the notions like logic, rationality, truth, knowledge, and intelligence. It is never easy to answer the question what exactly the science is. For some, science is what the scientists practice. For others, it is organized knowledge disciplines like physics, chemistry, biology, etc. But no one can answer this question exactly. This leads us to think a bit deeper. Science is a process of learning. It is very different from other areas of study because the way to learn science is to do science, because science is basically based upon the principle of learning by doing. You can propose it as a subject which always tests ideas with the help of evidences collected from the world around us. Coming to the domains of science, to think of science, we have to take into account its multidimensionality. Although it is more application oriented, but also based upon sound theoretical, philosophical, and sociological parameters. Whenever we talk about science, different interwoven domains come into our mind. Let us try to understand what these domains are. In order to do so, we have to enlist various activities, facts, and processes related to science. We can think of science as facts, concepts, theories, laws, and some methods and processes. While describing the nature of science, educators have converged on a key set of concepts like tentativeness, empirical evidence, observation and inference, scientific laws and theories, along with scientific method, creativity, objectivity, and subjectivity, etc. All these can figure in the major domains of science. To start with, three domains of science are considered in narrow terms. These three major domains of science are: number one, science as a body of knowledge, which includes facts, definitions, concepts, theories, and laws. Number two, the second domain considers science as a process of inquiry, which includes observing the phenomena around, measuring, estimating, inferring, classifying, hypothesizing, experimenting, and concluding. The third domain of science considers science as a way of thinking based upon the evidences, that is, to be creative and influenced by background knowledge. These three domains of science are the narrow domains of science. To take these further, 5 domains of science have been given by McCormick and Yeager in the year 1992. According to McCormick and Yeager 1992, there are 5 domains of science which are knowledge domain, process domain, creativity domain, application domain, and attitude domain. The 5 domains of science, knowledge, process, creativity, application, and attitude, as given by McCormick and Yeager, they say that too often science education is limited to the first 2 domains, that is, knowing and understanding, and exploring and discovering, which relate primarily to the product and process of science. They have emphasized that the 3 other domains must be included in these times of global environmental problems, complex social and political issues, and general concerns about the future. So, McCormick and Yeager, they have emphasized on creativity domain, application domain, as well as attitude domain, along with the knowledge and process domain of science. To address these concerns, the domain of imaginary and creating emphasizes the creative dimension of using science for the benefit of people. The domain of feeling and valuing looks at human values, feelings, and decision making skills. How to use information gained from school science studies in everyday life falls under the domain of using and applying. Coming to the characteristics of five domains, the first domain of science, that is knowledge, it refers to knowing and understanding. The focus of this domain is upon scientific information, that is facts, concepts, laws, hypotheses, and theories accepted by the scientific community. The second domain, that is process domain, refers to exploring and discovering, and the focus of this domain is upon processes of science, that is how scientists work and think. The third domain is the creativity domain. It refers to imagining and creating something new, and the focus of this domain is upon generation of ideas, designing and problem solving in a creative way. The fourth domain is the application domain, which refers to using and applying, and the focus of this domain is application of what is learned to do science, connections to everyday life, and making informed decisions. The fifth domain is the attitude domain, which refers to feeling and valuing, and the focus of this domain is developing attitude, sensitivity, societal issues, and impacts among the students. Coming to the details of the knowledge domain, science in the classroom has been viewed and practiced for decades as a body of knowledge or facts to be learned or absorbed by the students. Classically, this occurs through the memorization of facts and concepts from the textbook. Science facts are clearly important, but to memorize facts as if their acquisition is the sole purpose of science education violates the spirit and nature of science. So, science is a subject which should focus upon knowledge domain along with the rest of the four domains also. Science is a body of knowledge which includes facts, definitions, concepts, principles, theories, laws, etc. Many people talk about scientific knowledge about the planet and stars, etc. If you see any textbook of science, you can easily find various facts, concepts, definitions, principles, and theories associated with science. A few of them have lasted long and have been a part of scientific knowledge since generations. Some important characteristics of scientific knowledge are: scientific knowledge, it is tentative in nature. Scientific ideas are influenced by social and historical background. The objective of science is to provide explanation of natural phenomena, whereas the objective of technology is to provide solutions of problems related to life. The specific objectives which come under this domain are to enable the learners to learn specific information, that is facts, concepts, theories and laws of science, and to investigate knowledge of history and philosophy of science. By emphasizing on theories and principles, we can provide only factual knowledge to the learners, which is of no use to them. This only creates a burden on learners' mind, and gradually they start losing interest in science, as mentioned by Larson and Cindy in the year 2011. So it is high time that we should come up with a strategy to provide them with real experiences of science. The teacher should provide learners an opportunity to feel, experience, explore, and analyze. They will themselves generalize and develop their own body of knowledge. If you want to establish science as a body of knowledge, you have to plan such activities in which learners find out the concepts, principles, and theories after generalizing by themselves. Second domain is the process domain. When you start teaching and learning of science in your class, you have to go through various processes which will allow your learners to investigate about various important issues in their surroundings. Certain process skills have to be developed among the students, which are observation, inference, classification, communication, measurement, and prediction, etc. The process skills are important for scientific investigations as well as in everyday life. The learner should be able to establish causal relationships and distinguish them from mere associations. Science processes, often designated as inquiry skills, are embodied in the terms exploring and investigating. In science, the investigative processes require hands on and minds on activities, laboratory inquiries, and experiments that provide approaches for helping students understand various scientific concepts. A study conducted by Shevelson and Pink in the year 1992 found that students with experience in hands on activities could reliably note their own progress in laboratory activities. More important, these kinds of inquiry skills are also necessary for dealing with everyday life and play a role in the development of an understanding of the natural world as proposed by Aikenhead in the year 1979. So, the process skills which are used in science are observing, using space and time relationships, classifying, grouping, and organizing, using numbers and quantifying, measuring, communicating, inferring, predicting, identifying and controlling variables, interpreting data, formulating hypotheses, defining operationally, and experimenting. All these process skills, they are used in science in different contexts. The specific objectives which come under the process domain are: number one, the process domain uses processes of science to learn how real scientists think and work. That is, how they observe and describe, classify and organize, measure and chart, communicate, predict and infer, hypothesize, test the hypothesis, identify and control variables, interpret data, and construct instruments, simple devices, and physical models. The second objective of process domain is to use manipulative, that is psychomotor skills, as well as cognitive skills. For example, a classroom activity can be given to the students for the process skills, that is measuring. Students may be given a sugar cube, though not told what it is, a metric ruler, a balance scale, a steel pin, and a prescribed amount of water. They can be challenged to make as many observations and measurement as they can do of a cube, and to use as many of their senses as they can do in doing so. In a science classroom, the teacher is expected to provide opportunities to the learners to participate in some investigative activities which will help them to understand the nature of scientific inquiry. Such practices will encourage the learners to think about the relationship between facts, options, processes, and incidents. It is expected that you will encourage your learners to identify relationships and analyze rationally the associated facts. Third domain is the creativity domain, and creativity is known to play an integral role in the many processes of science and in doing science as well. If a science educator wishes to foster a classroom that enhances students' creativity, the classroom should probably become more student centered. Creativity is fostered and nurtured through richness in experiences. Creativity refers to openness in the classroom, acceptance of ideas, thinking outside of the box, try new things approach, and so called go with the flow approach. A creative person can create something new from the ordinary things around them. The attributes of creative domain are visualization, that is production of mental images, generation of metaphors, divergent thinking, imagination, novelty by combining objects and ideas in new ways, and creating extraordinary things from the common things from their environment. It also includes open-ended questioning, solving problems and puzzles, consideration of alternative viewpoints, designing devices and machines, generation of unusual ideas from the usual ideas around them, multiple modes of communicating results, and representations in various ways and modes in a creative way. Fourth domain is the application domain. A key element in the application domain is the determination of the extent to which students can transfer and effectively use what they have learned to a new situation, especially one in their own daily lives. Students must demonstrate that they not only grasp the meaning of the information and processes, but they can also make applications to concrete situations that are new to them. Basically, the application domain refers to the use of acquired new knowledge to a new situation or to their real life situation. The application domain is very important because it involves students using concepts and processes not only in a familiar context but in addressing new problems as well. Students who can apply what they have learned to new situations provide evidence that they have an understanding of a concept. So if we start with the knowledge objective, then the students must be given exposure of the understanding objective followed by the application objective. The attributes of the application domain are use of critical thinking, use of open-ended questions. Students, they will ask a number of questions, open-ended questions, while the teacher is trying to attain the application objective. Use of scientific processes in solving problems that occur in their daily life. So whatever knowledge they have attained, whatever they have understood or comprehended, they will try to use that understood knowledge in real life situation or in solving problems in their daily life. It also includes the abilities to make interdisciplinary connections, that is integration of science with the other subjects or other disciplines. It also includes the abilities to make interdisciplinary connections, that is integration of science with other subjects as well as the various types of sciences. Decision making related to personal health, nutrition, and lifestyle based on knowledge of scientific concepts rather than or near say or emotions. That is how the personal health can be improved, how balanced nutrition should be taken, and how healthy lifestyle is to be maintained. This is all application of knowledge of scientific concepts to the daily life of the students. Moreover, it also includes understanding and evaluation of mass media reports on scientific developments, that is critical evaluation of the mass media stories around us. It also includes application of science concepts and skills to technological problems, along with understanding of scientific and technological principles involved in common technological devices. The fifth domain is the attitude domain. It refers many times we have heard people say that they were never good at science, mathematics, or other area of study. Felker 1974 found that when students were induced to make positive statements about themselves, they attained more positive attitudes about themselves. Page 1958 indicated that teachers who reflected an active and personal interest in their students' progress were more likely to be successful in enhancing the personal confidence level of the students. Attitude is very broadly used in discussing issues in science education and is often used in various contexts. Two general categories that are distinguishable are as follows. First category is attitude towards science, which refers to interest in science, attitude towards scientists, and attitude towards social responsibility in science. And secondly, it refers to scientific attitude, that is open-mindedness, honesty, or skepticism. Interest in science tends to decline as students experience more science classes and progress through school. This is especially true in the middle schools when enrollment in science classes decline. Science educators need to work to retain student interest in science and need to consider changing both instruction and assessment practices to be more student centered in order to promote ongoing interest of the students as mentioned by Gardner 1975. Attitude domain, the attributes of attitude domain are as follows. First is the exploration of human emotions, expression of personal feelings in constructive ways, decision making about social and environmental issues. It also includes, the attributes include the development of more positive student attitude towards science in general, development of positive attitude towards oneself, development of sensitivity to and respect for feeling of other people. Although this attitude may seem beyond the scope of a science classroom, consider the words of Charles Swindoll, 1994. The longer I live, the more I realize the impact of attitude on life. Attitude to me is more important than the facts. I am convinced that life is 10% what happens to me and 90% how I react to it. And so it is with you. We are in charge of our own attitudes. Science is a way of thinking. Famous scientist Carl Sagan says that science is more than a body of knowledge, it is a way of thinking. On a wider note, you have to work for development of scientific thinking among your learners. Your success as a science teacher will depend upon the degree of scientific thinking and scientific attitude developed in your learners. Science as a way of thinking involves scientific temper, scientific inquiry, and a sense of humanity, accepting that scientific ideas are tentative and control of emotions while interpreting the evidences are its important ingredients. So, in the present session, we have discussed about the 5 domains of science. The characteristics and the focus of these domains have also been discussed. At the end of the session, it may be concluded that no domain can be segregated from the others and all the 5 domains should be integrated with each other while teaching science. Thank you.